Welcome and hello. This is a video tutorial in HEC HMS, and in this lesson, I'm going to talk about surface storage methods in subbasins. Inside a subbasin, we need to select a surface storage method. What I have on the screen is a subbasin as part of a watershed, and when I go ahead and click that, down here in the components editor, we have this surface method right here. These are the options we're going to talk about in this lesson. The surface storage dropdown in the subbasin component editor is used to represent the ground surface where water may accumulate in surface depression storage. So, for instance, if you have an impervious surface like a paved parking lot, it's going to have very little or zero surface storage. However, if you have some agricultural land, for instance, that could offer much more surface storage. Our options down here in the surface method include none, dynamic surface, gridded dynamic surface, gridded simple surface, and simple surface. These are the five we're going to talk about. I'm going to actually talk about them in the different order, however. I'm going to start with simple surface and then talk about gridded simple surface. And then we'll talk about the dynamic surface and gridded dynamic surface. Just taking a quick step back, I wanted to mention that any precipitation that falls and passes through the canopy, then that would intersect this surface that we're talking about. From then, the precipitation that hits the surface will fill the depression storage and infiltrate. If that depression storage is completely filled and the precipitation that passes through the canopy exceeds the infiltration rate, that's when runoff occurs. So I just wanted to kind of give a big picture of the whole precipitation to runoff process and where the surface fits in. Okay, let's go ahead and get started here. I'm going to start by clicking none, which is a valid option. Surface method is not required for simulation. When none is selected, the subbasin will not compute any surface depression storage, and all direct precipitation that passes through the canopy will be subject to infiltration. It's also worth mentioning that none is the default value for my HEC HMS, but you can change that. For instance, if you want a new subbasin to be initialized with a specific surface method, what you do is you go up to Tools, Program Settings, and then select the Defaults tab here. And then we're looking for right here, Subbasin Surface. So right now it's blank, so I guess that means none, but then you can change that value to any of the surface methods here, and then click OK. I'm not going to do that though. One other thing I wanted to mention while in the program settings is over here in the General tab, we have a couple of checkboxes at the top. This second checkbox here is what I have unchecked because a warning pops up whenever changing component method. So go ahead and uncheck that if you want. But basically, if you change from, say, none to dynamic or dynamic to any change on this dropdown or the other dropdowns here in the component editor, it puts up a warning message that says, hey, are you sure you want to change? Because you're going to lose all your data that's associated with that method you're changing from. So I have that warning disabled. Okay, so the first surface method that we're going to talk about after none is the simple storage method. And when I select that method, I get a surface tab right here next to the subbasin tab. So here's the surface tab. It's also worth mentioning that if I happen to select subbasin and then for transform method, I use kinematic wave. In that situation, I'm actually going to have a surface 1 tab and a surface 2 tab. But that's beyond the scope of this lesson. I will cover that when I talk about transform methods. All right, so back to what I had it as and simple. Okay, so to the surface tab. Here are the fields that we want to fill out for the surface tab. It's initial storage method, initial storage, and then max storage. I'm going to just start with the max storage first. So let's enter a value. How about 0.10? This represents the depth of storage, of depression storage for that subbasin. And then the initial storage, it might just be 0, like if it's completely dry. Or it may actually be a percentage. So if it was like half, like 50%, I put 50. Or I can specify it as a depth. So if it was a depth and there's 0, I would say 0. Or if it was 50%, I would say 0.05 inches. So that's how that works. And that's the simple storage method. So there's really nothing else to talk about there. Let's switch over to the gridded simple surface method. So that's changed. And now I'm going to go ahead and click surface. This should look similar. We have initial storage, but now I have to specify the percentage. So again, I could say it's 50%. I could say it's 0, whatever. And then after that, we have a storage grid that we need to select. This method implements a simple surface method, but on a grid cell basis, where each grid cell has a separate parameter value representing that maximum storage. So to do that, we're going to go ahead and click on Components and then Grid Data Manager. Now we need to select the data type. We're looking for Storage Capacity Grid, which is this one right here, and then click New. And then we'll give it a name. I just pasted in this name here. You can type whatever name you want. And then the description is optional. So I'll go ahead and click Create. I'll close my Grid Data Manager. And now up in the Watershed Explorer, I want to just confirm that that was added. And here it is, Grid Data, Surface Storage Grids. And then here's my Storage Capacity 45 grid. Down in the Components Editor, I need to define what that grid is. So I can put a description, that's optional, but then what's required are the next three fields. So I can specify a DSS file, an ASCII file, or a GeoTIFF. And then based on that data source selection, I would have to specify a few other parameters. So for DSS, it would be file name and file path. I'm not going to do that for this video. I'm just going to let you know that that is required. Let's again click on the subbasin and then click on surface. And now we should have our surface capacity 45 record here for the storage grid. All right, next up, we'll click on subbasin and change our surface method to the dynamic surface. And then now we'll click on the surface tab. So this is a little bit different. What's different is the infiltration method. So as before, we have our initial storage. It has to be in a percentage. And the max storage, which I'll say is 0.10 inches. Sure. Now, infiltration method is our options are pack and lee or specified infiltration limit. And this is going to be variable. One of the reasons why dynamic methods are developed is because of forest fires. So soon after a forest fire, you may have a somewhat impervious or hydrophobic layer with a much lower infiltration rate. And then as time passes, that infiltration rate will increase back to the normal or maximum infiltration rate. This method predicts the temporal and spatial variation of infiltration rates based on the date of the last fire, the percent burn, and the number of preceding storm events. So let's go ahead and talk about these two different methods. So pack and lee infiltration limit is the first one here. And then I'm going to talk about these fields and enter data as I do that. First is the date, and this is the date of the burn of the wildfire in the watershed. And I believe this is the last date. So the simulation date could be a day later, a week later, a year later, but this is the date here of the burn. Percent burn is the next field down, so we could just enter a percentage. So if the entire subbasin burned, we'd put 100%, or if less than 100% burned, then we'd enter that number. Next is the initial rate and the maximum rate, and this represents the infiltration. So the initial rate is going to be lower due to the fire, which leaves that hydrophobic layer and can form after a watershed burn. An example is 0.01. And then a maximum rate may be something like 0.40. And this is after the watershed has recovered. The surface infiltration rate limit will be updated for each time step of the simulation, hence the term dynamic. The rain intensity threshold in inches per hour, an example for that is 0.1 inches per hour. And this defines when an event occurs. So if there's rain, but it doesn't exceed this rain intensity threshold, it's not considered an event. The last field here is dry duration, and 720 minutes or 12 hours represents separate precipitation events. Okay, so these are the fields required for pack and lee infiltration rate, our limit method. And then the other one is specified infiltration limit. Again, we have these two fields up above that are the same, and then infiltration rate. This initial infiltration rate in inches per hour is the infiltration rate prior to the fire, or whatever constitutes initial for the simulation. After that, we have a percent gauge to represent the reduction of the surface infiltration limit due to fire conditions, which could allow for the infiltration rate to recover over time back to the pre-fire infiltration rates. So what we're seeing here is a drop down, and we need to select the time series for the percent gauge. What that looks like is similar to what the data grid that we already added, but this time we're going to select time series data manager. And for the data type, we're going to select percent gauge. So percent gauges, and then click new. Next, we're going to add a name for that time series data. It's going to be infiltration recovery 45 for subbasin 45. Create and close that. Okay, so let's go ahead and look at the data that's required. Here's our time series data. Inside that, we have percent gauges, and here's the percent gauge time series data that we just added. In the component editor, we need to specify the different data source, if it's manual or if it's a single or multiple DSS file. And then down below that, we need to specify a percentage, of course, and then the time interval and the that long. If we select a different data source, then we have a few different fields to provide, such as the file name and file path if we're using a DSS file. All right, let's go back to our subbasin and then select the surface again and just confirm that we can now select that time series data for percent gauge. I'm going to go back and select subbasin, and the last surface method is not dynamic surface, but gridded dynamic surface. So I'll go ahead and click the surface tab again. Again, we have the same initial storage percentage, so that would be, say, 0%. And the infiltration method at the bottom here is the two options that we had already and we already discussed, so I'm not going to talk about those again. The only difference now between gridded dynamic and non-gridded dynamic is this storage grid. So right now it's none. Each grid has a separate max storage parameter value. So before we just set a single value that was true for the entire subbasin. Now we have a grid to represent that value. It's also worth mentioning that these dynamic infiltration rates down here do not vary by grid cell. The only grid cell variation is for the max storage parameter, which is in this storage grid here. All right, well, that was it for this lesson. We talked about subbasins, specifically the storage method. We talked about these 4 different storage methods, as well as the required parameters to run them in a simulation in HEC HMS.